Imagine gazing at the horizon one day, expecting the usual sunrise, but instead you see the sky split into two, half consumed by a blinding light from a distant star that is now brighter than ever. It's not the sun, it's Betelgeuse. This colossal red supergiant is growing so large that if placed in our solar system, it would engulf the orbits of Mercury and Venus, possibly even coming dangerously close to Earth. Such an apocalyptic scenario might seem like science fiction, but Betelgeuse's fate is more than just speculation. One of the most fascinating stars in our night sky, Betelgeuse has captured the attention of astronomers for centuries. This star is a red supergiant, a celestial behemoth so large that if we were to swap it with our sun, it would stretch beyond the orbit of Mars and even extend through the asteroid belt. However, Betelgeuse, located around 700 light-years from Earth, poses no immediate threat to us. But as Neil deGrasse Tyson once pointed out, Betelgeuse is the closest star to Earth that will eventually end its life in a spectacular supernova explosion. Such an event, while far away in cosmic terms, would still have observable effects from Earth, sparking both awe and a sense of cosmic insignificance. Betelgeuse is not just known for its size, but also for its unique variability, a beautiful reddish-orange star that sits prominently in the constellation Orion. Betelgeuse's brightness fluctuates significantly over time. It's one of the few stars visible to the naked eye that exhibits such variability, sometimes becoming so bright that it rivals the brightest stars in the sky. Its apparent magnitude has been observed to range from 0.0 to as faint as 1.6, which is quite unusual for a star so prominent. In late 2019, Betelgeuse began to dim dramatically, causing excitement and concern among scientists and space enthusiasts alike. Some believed this marked the beginning of its end, the long-anticipated supernova explosion. However, Betelgeuse recovered its brightness by early 2020, and it became clear that this mysterious dimming was likely caused by a cloud of dust ejected from the star, temporarily obscuring our view. Nonetheless, this episode served as a reminder that the death of this stellar giant is inevitable, even if it might still be tens of thousands of years away. When discussing variable stars like Betelgeuse, it's important to understand that many other stars also experience fluctuations in brightness. Take, for example, Aldebaran and Riel. Both stars exhibit different levels of brightness depending on various factors like temperature, size, and distance from Earth. Aldebaran, the red giant in the constellation Taurus, can sometimes be as bright as Riel, one of the brightest stars in Orion. However, Betelgeuse's variability is especially notable because of its sheer size and its proximity to Earth. Betelgeuse's distinct variability is a product of its convective nature. As a red supergiant, Betelgeuse's outer layers are in a constant state of flux, with hot gases rising and cooling before falling back toward its core. This constant movement contributes to its unpredictable light output. The fluctuation in brightness is not just an optical illusion. It's a result of genuine changes occurring on the star's surface. Betelgeuse's significance is not limited to modern astronomy. Its name is rooted in ancient culture and language, specifically from Arabic, where it roughly translates to the armpit of the giant. This reference to the star's position in the constellation Orion has persisted throughout centuries, although its exact etymology is still debated among scholars. Variations in its name, from Beel to Betelgeuse to the lesser-known Belage, illustrate the star's far-reaching impact on human understanding of the cosmos. In mythology, Betelgeuse has been associated with various gods, heroes, and creatures across different cultures. In Brazil, for instance, the star is seen as part of a turtle's leg, while in Japan, it represents the limb of a ceremonial drum. The Lakota people of North America viewed it as the severed arm of a chief, while in Hindu astrology, it is connected to the lunar mansion Ardra, ruled by the storm god Rudra. The star's prominence in human history is further highlighted by its frequent mention in the myths of Orion. Often seen as a warrior or a hunter, Orion has been a significant figure in the night sky for millennia, with Betelgeuse marking his right shoulder. This star's redness has often been interpreted as a symbol of danger or impending doom, particularly in cultures that associate it with war, death, or the god's wrath. Astronomically speaking, Betelgeuse is nearing the end of its life cycle. At around 10 million years old, This red supergiant is relatively young compared to our Sun, which is about 4.6 billion years old. However, massive stars like Betelgeuse burn through their fuel much faster than smaller, less massive stars. This rapid consumption of energy means that Betelgeuse will soon, on a cosmic timescale, run out of nuclear fuel, causing its core to collapse under its own gravity and triggering a supernova explosion. When this happens, the explosion will be catastrophic, producing a burst of energy so bright that it will outshine entire galaxies. From Earth, we would witness a light show like no other. Betelgeuse would shine as brightly as the full moon for several weeks or months, even during the day. After the explosion, the star would eventually fade, leaving behind a neutron star or black hole, depending on the mass of its remaining core. Such a supernova would have profound effects on Earth, though fortunately, Betelgeuse is far enough away that we wouldn't be directly impacted by the radiation. Supernovae that occur within 50 light-years of Earth pose a real threat to life due to the intense radiation they emit. However, Betelgeuse's distance of approximately 700 light-years means we are safe from any dangerous radiation that might be produced. Supernovae are among the most powerful events in the universe, and they have been observed and recorded by humans throughout history. One of the brightest supernovae ever recorded occurred in 1006 when a star in the Milky Way exploded, becoming brighter than Venus in the night sky. This event was visible to people all over the world and was documented by astronomers in China, Japan, and the Middle East. In more recent history, a supernova in 1987 exploded in the Large Magellanic Cloud, a satellite galaxy of the Milky Way. This event, known as SN 1987A, was the closest supernova to Earth in centuries and provided scientists with valuable insights into the life cycles of stars. If Betelgeuse were to explode, it would be the first supernova visible to the naked eye in over 400 years. Its proximity to Earth would make it an unprecedented opportunity for scientific observation and public fascination. Scientists would be able to study the remnants of the explosion in great detail, learning more about the physics of supernovae and the future of our own Sunday. The big question on everyone's mind is, when will Betelgeuse finally explode? Despite the star's dramatic dimming in 2019, scientists agree that Betelgeuse is unlikely to explode anytime soon. While it could happen tomorrow, it is more likely to occur within the next 100,000 years, a blink of an eye in cosmic terms, but far beyond the span of a human lifetime. Astrophysicists continue to study Betelgeuse's behavior using advanced telescopes like NASA's Hubble Space Telescope to monitor its fluctuations. While Betelgeuse dimming was initially alarming, further research has shown that this was likely caused by a surface mass ejection, SME, a process where a portion of the star's surface is blown off into space. This event, which ejected 400 billion times more mass than a typical coronal mass ejection, CME, from our Sun, temporarily obscured Betelgeuse's light, making it appear dimmer to observers on Earth. If Betelgeuse does explode, what would we see from Earth? The light from the explosion would reach us after traveling across 700 light-years of space, lighting up our night sky like nothing else for weeks, possibly months. Betelgeuse would shine as brightly as the full moon, casting shadows on Earth at night and being visible even during the day. After the initial burst of light, Betelgeuse would begin to fade, leaving behind an expanding cloud of gas and dust. This nebula, visible for centuries to come, would be a lasting reminder of the star that once dominated the night sky. For astronomers, this would be a rare and invaluable opportunity to study the remnants of a supernova up close, gaining insights into the processes that govern the death of stars and the creation of neutron stars and black holes. In the end, Betelgeuse is not just a star. It is a symbol of the mysteries and wonders of the universe. Its variability, its size, and its impending explosion have made it a subject of fascination for scientists and the general public alike. Throughout history, Betelgeuse has been a source of inspiration for mythology, literature, and art, and its eventual explosion will be one of the most significant astronomical events of the 21st century. As we continue to observe Betelgeuse and await its final act, we are reminded of the fragility of life in the cosmos. Stars like Betelgeuse live fast and die young, burning through their fuel in a matter of millions of years. When they die, they do so in spectacular fashion, scattering their elements across the universe and contributing to the formation of new stars, planets, and possibly even life itself. What do you think about Betelgeuse and its potential explosion? Betelgeuse's eventual supernova explosion represents one of the most awe-inspiring events we could witness in the universe. A cosmic spectacle that would leave an indelible mark on both science and culture. While its dramatic dimming in 2019 generated widespread interest, many astronomers are continuing to track the star closely, hoping to gain further insights into the processes leading up to its inevitable demise. What makes Betelgeuse so fascinating is not only its size, variability, and impending end, but also the rich history that surrounds it. The study of Betelgeuse has offered numerous clues about the life cycles of massive stars, the origins of elements, and the evolution of the cosmos itself. One of the remarkable aspects of Betelgeuse is its status as one of the most studied stars in human history. Astronomers have long recognized the importance of understanding the life cycle of such a massive star, as it can provide critical information on stellar evolution. The red supergiant is thought to have formed relatively recently on the cosmic scale, roughly 10 million years ago, but it has already exhausted much of its hydrogen fuel. Unlike smaller stars like our Sun, which can burn steadily for billions of years, Betelgeuse's short life is a result of its immense mass, which accelerates its nuclear fusion processes. This rapid consumption of fuel means that Betelgeuse will soon run out of the resources it needs to sustain itself, eventually collapsing in on itself. The collapse of Betelgeuse's core will trigger a chain reaction that will lead to a supernova explosion. This process, though violent, is an essential part of the stellar life cycle. The explosion will release an enormous amount of energy, scattering heavy elements such as iron, calcium, and oxygen into space. These elements are crucial for the formation of new stars, planets, and even life as we know it. In fact, many of the elements found in our own bodies were likely forged in the hearts of stars like Betelgeuse. Thus, the death of Betelgeuse will contribute to the ongoing cycle of stellar birth and death that shapes the universe. The study of Betelgeuse's behavior offers astronomers a window into the mechanisms that govern the evolution of massive stars. Scientists have been using sophisticated tools like the Very Large Telescope, VLT, in Chile and the Hubble Space Telescope to monitor the star's fluctuations, carefully analyzing its light curves and spectral data. These observations allow researchers to track the changes in the star's outer layers and better understand the forces at play in the star's interior. Although Betelgeuse has experienced significant dimming events, its eventual fate remains uncertain. Whether the dimming signals an imminent supernova or is merely a natural part of the star's long-term behavior is still open for debate. As Betelgeuse nears the end of its life, its core will begin to contract under the force of gravity. This will cause the outer layers of the star to expand, eventually creating the red supergiant that we see today. Once the core has contracted sufficiently, the temperature and pressure will rise to such an extent that the star will begin fusing heavier elements. The resulting fusion reactions will create a massive explosion that will release an enormous amount of energy. The shock wave from this explosion will travel outward, disintegrating the star and scattering its outer layers into space. This violent release of energy will be the supernova that we would see from Earth, lighting up the night sky like nothing else. For observers on Earth, the explosion of Betelgeuse would likely be a life-changing event. The star's explosion could shine with the intensity of the full moon, casting shadows on Earth even during the day. This burst of light would likely be visible for weeks or even months, and the remnants of the explosion could remain visible for centuries as an expanding nebula. The debris from the explosion would contain a wealth of information that could shed light on the physics of supernovae, stellar nucleosynthesis, and the creation of neutron stars or black holes. By studying the remnants of Betelgeuse's supernova, scientists could learn more about the forces that shape the death of stars and how these processes contribute to the formation of the building blocks of new celestial objects. While the supernova itself would be a spectacular sight, it's important to note that it would not pose a direct threat to life on Earth. Betelgeuse is located about 700 light-years away, which is far enough to keep us safe from any harmful radiation that might result from the explosion. Supernovae that occur within 50 light-years of Earth are capable of producing radiation levels that could harm life on our planet, but Betelgeuse's distance ensures that we are not at risk. Even so, the explosion would have profound effects on the surrounding space, creating shockwaves that could influence nearby stars and potentially trigger the formation of new stars in the region. Looking beyond the immediate future of Betelgeuse, the study of stars like it also serves as a reminder of the vastness and dynamism of the universe. Our Sun, much smaller and less massive than Betelgeuse, will one day go through a similar process, though on a much longer timescale. When our Sun eventually exhausts its fuel, it will expand into a red giant, shedding its outer layers and ultimately collapsing into a white dwarf. While this process will not result in a spectacular supernova, it will still have a profound impact on the solar system. The study of Betelgeuse and other massive stars offers us a glimpse into the future of our own solar system and the eventual fate of our Sun. As astronomers continue to study Betelgeuse, they are also gaining valuable insights into the broader processes that govern the life cycles of stars. The knowledge gained from observing this massive star will help us understand not only the past and future of stars like Betelgeuse, but also the origins of the elements that make up everything around us. As we await Betelgeuse's final act, we are reminded of the ever-changing, unpredictable nature of the universe and our place within it. The explosion of Betelgeuse will mark the end of a stellar era, but it will also serve as a testament to the incredible forces that shape the cosmos.